Alright folks, we're back for section 9.3. 9.3 introduces real trig functions, and in order to find angles for these trig functions, but without using a calculator. Now obviously right now I can't take your calculator away from you, so I mean use that how you're going to use it, but this is just basically how I use a unit circle. Now a unit circle is something that looks like this. Alright, this unit circle is very, very important, but notice it only shows very specific angles. It shows angles 30, 45, 60, 90, and so on, and it also shows radians. Now, before we kind of move on, I'm going to kind of talk to you about radians just a little bit. Remember we said that radians are either 0 or 2 pi. Oops, I gotta do this. Hang on. There. So, radians are either 0 or 2 pi, like this, or they're pi on the other side. So, a full circle is either 0 pi or 2 pi, or a half circle is pi. Now what they basically did was they arranged this into like pieces of a pie. So if you think about this, if I look at this one right here, and this one right here, and then I draw this line, there are 3 pieces of pie, right? There's one here, and there's one here. So notice every one of those lines is pi over 3, then another pi over 3, then another pi over 3. Pi over 3, 2 pi over 3, and then 3 pi over 3 is the same thing as pi. The same thing happens down here. See how it's broken up into 6 pieces of pie? 1, 2, 3, 4, 5, 6. That means that I still have pieces of pie. I can do the same exact thing with every single one of these. Alright, watch. So I can break it up, and let's say that we want pi over 6. So if we're looking at pi over 6, there's pi over 6 here, and then pi over 3 is the same thing as 2 pi over 6, and then we have 3 pi over 6, and then we have 4 pi over 6, 5 pi over 6, 6 pi over 6. So I have six different things. So if you're ever asked to create your own specific set of radians, that's how you do it. You just divide the top part into the certain number. If I wanted like pi over 7, just split the top part into 7 parts. Okay, that's what it really looks like. But now that's kind of off topic. That just has to do with radians. So when you look at this, basically what we're doing with a unit circle is we're looking for different values. Now this thing right here is super important. Okay, because it tells you that cosine is equal to the x value in your order pair, and then it tells you that the sine is equal to the y value. So if I wanted to know what cosine of 30 was, so if I wanted to know cosine of 30, I would look at 30 right here, and then I just look at this value right here, and I would know that the cosine of 30 without typing it into my calculator is the square root of 3 over 2. If I wanted to know the sine of 225, I would go to 225 right here, and then I would see that the sine of 225 is negative square root of 2 over 2. So it's really nice because it actually makes things a lot easier for us. But that also opens up a different beast, because then it makes it so that it's specifically the exact value, right? And so now the other thing to think about with a unit circle, notice this point right here, the distance from 0, 0 to 1, 0 is exactly 1, so the unit circle has a distance or a radius of 1. Okay, so what that means is, I'm going to erase, actually I don't have to, hang on, I'm still learning how to use this. I want whiteboard though. There. So the difference with this is, all you have to really pay attention to is, we have to pay attention to sine is really the same thing as the y value, which is what we just said, but it's going to be divided by whatever the radius is. Now what we just did on the unit circle, the radius was 1. Cosine of theta is going to be equal to the x value, but it's just going to be divided by the radius. So if we were dealing with a circle that had 5 as a radius, we would just put 5 on the bottom. It really doesn't make it that much more challenging. Now tangent of theta is equal to equal to y over x. It doesn't matter what the radius is for this, it's always just going to be y over x. Now again, all we have to do if we want to find the other trig functions, like cosecant or secant or cotangent, just flip them, right? So if we're really looking at this, we're saying that cosecant, oops, CSC, we're saying that cosecant of theta is equal to, come on, r over y. Secant of theta is equal to r over x, and then cotangent of theta is equal to x over y. Now at the bottom of this sheet, at the bottom of this unit circle, it's kind of nice. Give the computer time to catch up for a second. So at the bottom of the sheet, it's really nice because you're going to notice that it already tells you what cosecant is, it already tells you what secant is, it already tells you what cotangent is. Okay, so it actually already tells you those things, which is really, really nice because it kind of takes the thought process away from you. It lets you remember that it's just the reciprocal. Alright, so moving on into something else, this is just, if you're ever interested in why this is, then you can kind of look at a circle, and we can say that we have this. If I'm looking at any angle, it doesn't really matter what that angle is, but if I have some angle and it looks like this point right here is going to be given by some xy value, right? That point out there, because it's some point in space, is going to be given by an xy value. Now if I go like this, I can make a triangle. This value right here, this blue line that I just had, is the y value, right? And then if I do the same kind of idea, and we go, oops, I already used that color. Can you guys see me choosing colors? I don't know. This thing right here, this is really the same thing as the x value. So if I want to figure out the distance of this radius, or the radius should be x squared plus y squared equals r squared. So it's all just related to each other, but we know that in a unit circle this is just going to be 1, so it just tells us that the radius is going to be 1. Okay? So now let's look at an example of what this looks like when it's all said and done. If I have a circle, and this circle looks like this, okay, and then it tells me that I have a point down here, and this point is 3, -3. So this point is 3, -3. The directions for this would be to find all 6 trig functions. Okay, so the first thing that I would have to do is I would have to figure out what the radius is. In order to figure out what the radius is, you just use the Pythagorean theorem. It's going to be 3 squared plus -3 squared equals r squared. So it's going to be 9 plus 9 equals r squared. So then r squared is going to equal 18. So r equals the square root of 18. Now we don't have to do plus or minus here, but what we have to do is we have to simplify this radical. Remember, this will break down into the square root of 9 and the square root of 2. So this is really going to be 3 times the square root of 2. So I'm going to have r equals 3 times the square root of 2. But now just remember what we just said. We said that sine is y over r. We said that cosine, so I'll write those down. Sine is y over r. We said that cosine is x over r. And we said that tangent is y over x. So we've already found out what r is. Y and x are given to us in this equation right here. So if I want to figure out what these things are, all I'm going to do is I'm just going to plug them in. So I'm going to say sine is equal to the y value, which was -3 over 3 times the square root of 2. I can simplify now, right? I can say 3 and 3 will cancel. So this is saying -1 over the square root of 2, but it's not okay to have a radical in the denominator, so I'm going to multiply it by the square root of 2 over the square root of 2. So this is just going to tell me that it is the negative square root of 2 over 2, right? And this would be really nice if they actually gave us the degree, because then we could just look at the unit circle, right? So we could just look at the unit circle, but I'm just showing you a different way to do this because it doesn't technically give you what this degree is right here. Alright, so now we look at cosine. Cosine is equal to the x value over the radius, so it's going to be 3 over 3 square roots of 2. So then it's going to be, oops, oh, I don't know what I just did. This and this will cancel. Oh, I don't know if you guys can see that. That was weird. Alright, so 3 over 3 square roots of 2 is the same thing as 1 over the square root of 2. Using the same concepts from above, this will just turn into the square root of 2 over 2. And then finally with tangent, if I want tangent, tangent is just going to equal the y value over the x value, so -3 over 3, which is just -1. So now, if I want to find the cosecant, the secant, and the cotangent, all I have to do is flip them. So this is really, really nice, because all I have to do is flip it. So now I'm going to end up getting 2 over the square root of 2, but it's going to be negative, and then I just have to multiply by the square roots, so it's going to end up being 2 square roots of 2, so it's going to be 2 square roots of 2 over the square root of 2 times the square root of 2, which is going to end up being 2 square roots of 2 over 2, which is the same exact thing as the, and it should be negative square root of 2. Okay, so that's the cosecant. If I want the secant, I'm running out of room here. The secant, I'm going to do the same thing. 2 over the square root of 2, but I have to get rid of these, so I'm going to multiply that by the square root of 2 and the square root of 2. So I'm going to end up getting the same thing, except it's going to be positive, so it's just going to be the square root of 2. And then if I flip -1, it's just going to be -1 for cotangent. Okay? So again, I know that could have been a little bit confusing, but just kind of pay attention to what the reciprocals are. This is all just simplification. At this point right now, there's absolutely no new math. This is just simplification. All right? So, the next part of this chapter, or this section, is all about something called reference angles. Now, reference angles are really, really easy, because what a reference angle is, it's basically the shortest angle from the terminal side to any x-axis. Alright? It's the shortest side from the terminal angle to any x-axis. So basically, if I have an angle that looks like this, and it opens here and here, the shortest distance from the terminal side to the x-axis, this thing right here, is actually the reference angle. So that is the reference angle right there. I know that this is the big angle right here. That's the big angle. The black angle is the reference angle, and that's just what the angle really is. So if it asks you for a reference angle, that's what it's looking for. All right. So if I want to find a reference angle for -130. If I look at where -130 is on here, I don't know if you can hear my kids screaming downstairs. They're playing Frozen stuff. My angle at -130 will look like this, right? So -130 looks like that. But that's not the angle that I'm interested in if I'm asked for the reference angle, because the reference angle is this distance from here to here. Now, -130, and then if I were to continue on this angle to right here, it would be -180. So the difference between those two is 50 degrees. The distance, remember, it's the distance from a terminal side to the x-axis, so that means that it's going to be positive. So the reference angle for -130 is 50. If I look at radians, and I want to find a reference angle for 5 pi over 3. Now this is exactly what I was talking about before. This is always going to be 2 pi, this is always going to be pi, and then this thing right here tells me how many pieces I'm going to split it up into. Okay, so I'm going to split this into 3 total pieces on top. So I'm just going to go like this. Now this is going to be pi over 3, this is going to be 2 pi over 3, and this is going to be 3 pi over 3. And then I'm going to do the same thing to the bottom and then just label them. So 4 pi over 3, 5 pi over 3, and then 6 pi over 3 is the same exact thing as 2. So I've already got that. So now what it's saying, because I had to create this picture, if I want 5 pi over 3 right here, that's what that angle is, and it's going to open up all the way around. It's asking me for this distance from this part to this part. And what's the distance from 5 pi over 3 to 6 pi over 3? The distance is just going to be pi over 3. So that tells me that my reference angle is going to be pi over 3. Alright? So I know this video is getting a little bit long. I'm trying to wrap it up. We only got another example or two. So what it wants us to do right here is it wants us to evaluate the trig function without a calc. So it wants us to evaluate the trig function without a calc. And it says cosine of -120 degrees. Now the easiest thing for me to do with this is I like to look at this as what's the real angle, because I don't like -120. But if I look at where -120 is, I can do this, and I can think logically through this and say, okay, if this is 90 down here, then -120 is going to be somewhere down here, right? So -120 is going to look something like that. So now if I really want to think of, actually hang on, rewind, because I wrote this wrong. My brain isn't thinking correctly. So undo. Alright, I want -210. So if I want -210, -210 looks like this. So I have this, and then I go around 180 degrees, and then up here. So the reference angle for this right here is going to be 30 degrees. They might want you to try with the reference angle, but I don't think that's the easiest method. What you really should think about is this is the same thing as 150 degrees. So the cosine of negative 210 is the exact same as the cosine of 150. And if we look back at our unit circle, so this is the same thing as finding the cosine of 150. So I look back at my unit circle. I look at the cosine of 150, which is just the x value here. So x value of 150, and the x value is the negative square root of 3 over 2. So I can just say that this is the exact same thing as negative square root of 3 over 2. And that's my final answer for that one. Alright, so now very last example that we're going to do is find the exact value of secant of 11 pi over 4. And so now we need 11 pi over 4. Now, what I like to do is I like to convert this thing using coterminal angles. So I'm looking at my unit circle. Oops, that's not what I want to do. I'm looking at my unit circle. And on my unit circle, I'm counting to 11. So I'm basically just counting to 11. Okay? So this is what I'm going to count to 11, or this is how I count to 11. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, right here. So that means that this is the exact same thing as 3 pi over 4. I just went around the circle a couple more times. So now, this is the exact same thing as saying the secant of 11 pi over 4. So what I want to think of this as, and this is super important because you're thinking, okay, this is a reciprocal. What I'm going to do is I'm going to do secant of 4 over 11 pi. This is not right. You cannot do this. What you have to think of this as is I will find the cosine of 3 pi over 4. Oops, I wrote the wrong thing. This is the same exact thing as secant of 3 pi over 4. What I have to think of it as is the cosine of 3 pi over 4. And then I'm going to get my answer, then I'm going to flip it. So I'm going to look here, then I'm going to look back at my unit circle. The cosine of 3 pi over 4 is negative square root of 2 over 2, right? So the cosine of that is negative square root of 2 over 2. So this is equal to negative square root of 2 over 2. And now if I want to find the secant, I just flip this. So I flip that thing. So now the secant is going to equal negative 2 over the square root of 2, and I just have to get rid of those square roots. So this is going to be negative 2 square roots of 2 over 2. I can cancel, and then I'm left with negative square root of 2. Okay? Now, this may be really challenging without a calculator. It kind of is what it is. This is a tough thing that you have to start dealing with. It's also a lot more difficult because I can't actually show you things face to face. So if you guys have questions, please make sure that you're asking it. I know this video is long. Take breaks if you need it. Pause it at 10 minutes. Find a good stopping point and come back tomorrow if that's what you need to do. I understand. You guys haven't heard my voice in a very, very long time, so I know it gets boring very, very quickly. It's hard to hear myself talk for this much, too. So if you have any questions, please make sure that you ask. I'd really like to hear from you. If you have anything that you would like to see, anything that didn't make sense, please make sure that you let me know. Alright, catch you next time.